everybody, welcome again to this new WeeW episode for the STM32F1, and we are focusing on the timer. This time we are going to use a timer and all the functions that we have created in the past videos to create a driver for the electronic speed controller that will be usually driving a brushless motor. And as you can see today, we have already, this is the example of the function that we will create within this video and to see how we will control. So we do have our ESC and motor ready and everything in place, and we are going to control the motor speed using this potentiometer. So as you will see here, by moving the potentiometer, I will have a very tight control on the electronic speed motor. So within this episode, you will learn how this electronic speed controller is controlled, and also to build a function that will give you a really strong control. Okay, so let's start together. Within this video, we are going to continue within the STM32F1 timer series. And this time we're going to build a driver for one of the most important stuff or hardware we do have in the Arduino world, which is the electronic speed controller. And as usual, the code that we are going to write is available on GitHub, so that's a good opportunity for you guys to just follow and understand what's going on. The language is only C, and the program to code will be Kale version 5. Finally, you will need to have a review on the first videos related to the timer series, so you will have a full understanding of what's going on. From the hardware perspective, we're going to use, as usual, the STM32F1 based board, which is the aka Blue Pill. We will need a potentiometer, also an electronic speed controller, an ESC, a brushless motor to see the rotations with a propeller, and finally I'll be using a 12-volt DC power supply, which will have a 30 amp as an output, or you can use a 3S LiPo battery. Okay, so from the tutorial perspective, first of all we are going to deep dive on the ESC operations, then we will have the circuit review. After that, there is a very important notice that I really recommend to stop by for a second. And finally, we are going to jump to the code and make some testing. So for the ESC operation, so let's take a quick look on the electronic speed controller. So this is mainly used for driving motors and the kit especially for the brushless motors. And the PWM is used to control the speed related to this one. And also, you have to follow a certain, to confirm the operation of a certain ESC. There's a main thing to review is how many voltage it can take and also the amperes it can handle. After that, for the users, there's a multiple of users, but the one that you are seeing here is used in both for make USC or RC cars. For the connections, same as the servo, there is a VCC and the ground and PWM input. But at the opposite of the servo, this one can be using the 3.3 volt from the STM32F1, so there is no need for any external input or a battery. And finally, for the driver, same as the servo, it's using a 20 millisecond of PWM period, but still you have to make the cycle is between 1 and 2 milliseconds. However, you'll need to make some testing to see the right operations. What I advise you to do is really testing and see how it's going on. And the expected motor start or the start of the rotation or revolution that you will have will be at usually 1.05 seconds. Okay, so let's take a look at the circuit that we are going to use within this tutorial. So we will take the STM32F1 Blue Pill. We are going to connect the PA1 as ADC input for the potentiometer, and this is to drive the rotations of the ESC. After that, we are going to use the PA8 as an output for the PWM for the ESC. Then we are going to connect it with a 12 DC power. And after that, and after confirming that every cable is connected at the right place, at the right thing, and our PWM is working properly, we can add also the connection to the power, the home power, which is for me 110 alternative current. Finally, when we confirm the operation and we heard some noise, we can connect to the motor so we are sure that everything is working properly. And again, You don't put your all system, the power system on only and only you are sure that every connection is correct, and you do have your microcontroller ready to fly and also at 0 PWM or 0% of your speed. Okay, so here comes the important notice, and this is something extremely important that I would like to be very cautious for everyone that will be using the system. So this is the risk that we do have. First of all, there is far more than 100 milliampere that can be very harmful. And we are talking here about 10 to 20 ampere, and this is very dangerous for people. So be very careful when you set up your circuit for the power system. Second one, the propeller can cause significant injuries, so it's good to be far from that. So, and you have to be very, worry and careful about where to put the system and be far from it. Then there's overheating situations and can cause explosion. So it's very important that you have the right dimension for each part. So you, for example, your ESC have to take more than 30 amperes, so you're sure that there is no big overheating or any risk of explosion. Okay, so this is my advices. First of all, double check each time all your connections that are good between the ESC motor and also the battery. Also, you have before powering the ESC, be in a safe distance. That's very important. Always confirm that your microcontroller have the right operation when you're powering the ESC. Means the PWM must be at 0. You imagine you are putting a high PWM and you are putting on power your ESC, something can go wrong. So just careful also about this. And always plan emergency stop in your program. So if you do have a complex program, always prepare very simple escape plan that will help to stop everything in case of things goes out of control. Because the truth is, when you put everything in motion and things goes out of control, it one of the most important things is to be ready to stop your program at the fastest possible way. Then always have an emergency stop switch, and this is what we had in our diagram. So we do have an emergency stop, so we can cut the current immediately. And also keep others far from your system. So when you're going and trying to do your experiment, be in a room by yourself, or make sure that everyone is far from you, so there's no people that can like tamper with your system when you're working with it. And finally, if it's possible, wear safety glasses. So I hope you got the message here. We are going to work with some stuff that are really cool, but we have to be careful to enjoy as much as possible the experience. Then when we went through everything, let's try to put the ESC driver and start testing. We are starting again at our program where we have finished the previous time. So as usual, we are going to use this ADC to read the data from the potentiometer, and what we are going to do in our while loop, we are going to read 50 times the data from the analog digital converter, and after that get the average. And this is to have a clean and clear, well average value, so we don't have a dancing data, because this is really low quality potentiometer that we do have. On the other hand, so let me show you what we do have. So we do have on this side the microcontroller, and we do have, this is our potentiometer connected to our PA1, and here we do have the signal coming from, so actually the wires coming from the electronic speed controller connected here. So this is the ground, this is a signal which is connected to PA8, and this is the 3.3. And on the other hand, we do have here, this is our C voltage supply for the DC 12 volt. This is our electronic speed controller, and there the motor and the propeller. Okay, so, and I added also on top of that, just to be sure before running our electronic speed controller, I added here this wire in, as you can see in orange, to the logic analyzer, so we are sure that we are getting the right output before start running our actually electronic speed controller. Okay, so let me go back and go here. So what we need to do is quite very simple. So we do have this variable speed, which is equal 0. And what we are going to do is put speed is equal to 1000. So we would like to start from 1000, whatever happened, plus. So let's put between parentheses, and we take the average analog value. We multiply by 1000, and we divide after that by 4000. And this to give us a value between 1 and 1000. So we have a really good unit of measuring or of control for the brushless motor. And after that, it's simple. What we need to do is put the timer function that we created, PWM, the micro, because we would like to work on microseconds, and it will be, let's use at the beginning 18,000. Because that's doing after some testing. But before that, we have to set up, we would like to use the PA8, so the port A pin number 8, and our auto reload value would be 18,000. And here we will put the speed. So this will be our speed. Okay. Let's save, build, and load. Okay, 0 error, 0 warning. So let's use now the logic analyzer and hide this one to be sure that everything goes well. So let's make it a little bit smaller, remove this one, and keep reading. So right here, let's close and keep reading here. Let's make it smaller. Perfect. So let's play a little bit to see what's going on. It should get a little bit bigger, but as this is between 10% and 20%, let's first put it at max in one side to see where we are. So if I stop here, you can see here I have almost 1000 microsecond, and this is exactly what I need. So this is my minimum. So let me see it again and change it to the other opposite here, and pause it and take a look. So we do have here 2000 actually microseconds, which is exactly what I need on the other hand, and this is the maximum value. So let's run it again, put it to the new minimum, put it back to this new minimum, and check. So we are at 1 millisecond. So if we can zoom, it's exactly 1 millisecond, and this is exactly what we need. And now let's make a quick test and see what's going on. So I don't really need this one for the readings, but I will keep it anyway. And I'm going to power my, let's put it here so we can, now that will not be clear, this is better. So let's power my, actually the DC voltage. So you will hear some sound and should be kind of a maybe. Let's hear. And this says that it's reading and it's ready to jump. So the signal, the PWM that we do have initially is perfect. And let's start playing a little bit to see what's going on. So I start really small and it started. So let me accelerate. And the more I turn, the stronger it is. And you can see we do have a very smooth control on our electronic speed controller. That's perfect. So we exactly have an expected value. So now let me stop the power and close it. So now I close the power and I can go back to my code to make the function. Okay, let's go back to the code here and wrap everything in the function here. So I prepared some space for the electronic speed controller, and let's put a char here, and it will be ESC, and we call it speed. So this is what we want. And the char will be, we will need a port. We will need a char also for the pin. And finally, a last one, we would like the int for the speed. Okay, that's perfect. So let's go within the function and start updating, saying first of all, if my speed is more than 1000, so if speed is greater than 1000, then we will return 0. So this is not acceptable value here, and we return a 0. And after that, we can do, so we put the int, and we can give it a name more representative. So we call RPM speed, but also we add here PWM, because this is what we have. It will be the initial value 1000 plus, here, where is it? So let's put it plus and speed. And that's all. So that's what we would like to have. And finally, we add the timer PWM micro, and we put here the the port that we would like to use, then the pin, and after that, the RPM speed that we have set up. Okay, brilliant. So I do have some issue here. So what does it say? Yeah, I know, because I have to put the 18,000. My auto reload value should be 18,000. I hope I did put the 18,000. Now that's 18,000, and we can return a 1 just in case. Okay, and let's add a new line at the end. Copy this one. Go to, let's close this. Go not the ADC, close this, and go to timer H, and jump 1 and put it here. We don't forget the comma here, and we are good. So we go here. So what we need to do is to take another line here, and we are going to average it again. So this one will be equal the average multiplied by, like this. Okay, and we can add here 40, because the maximum value is 4096, but the potentiometer is not really good. So if you put like 40, should be enough to have 1000. We can delete this, and what we can do, let's put it here. Speed is better, like this. This is my speed, so my speed will be between 0 and 1000. That will make a lot of sense from controlling perspective of the motor. And finally here, what we would like to add is the ESC speed, and we just put the pin, so the port, and here the pin number plus the speed. And this will be perfect if you would like to make a control application, so you do have a scale from 0 to 1000. Okay, so let's save. Okay, let's put, and as usual, first thing to do, just to check if our code is working properly. And now we are, so let me hide this and play a little bit. So let's put at the maximum to see what's going on. So we are at 1900, so it's almost the 2000, because I put it the 4040, which is still very, very good. And let's put on the other side, so let's move it to the other side, which should make it 1000. Yeah, it's 9990, like it's almost 9000, so 1000, so which perfect. Okay, so now I'm going to power again my DC voltage supply, and we should hear the ESC noise, which is good. It's ready now, and I will start moving a little bit, and it starts turning as good as it is. And you can see we do have a function that will help us to clearly have everything. So let me show it again. Here, where is it? Yep. So we do have, it's one function going from 0 to 1000, and this will control the speed of the motor. Okay, I hope you enjoyed this video. It was quite simple and easy, but now you do have really nice control on your motors. Thank you and see you in the next episode.